Okay, next we're going to look at some complex numbers and graphing these in our rectangular system and graphing them in our polar system. So what we have right here is our number z equals 6 plus j4. And so this is a complex number. And the first thing I'm going to do is recognize my axis here. So I've got the 6 here. This is going to be similar to my x and my y, except that this is going to be my j-axis here, okay, my imaginary axis. So graphing this on the rectangular one is going to be pretty simple. The hardest part is going to be realize that, oops, I should have had this go all the way to 6. Oops. All right, that's fine. That'll work. So I'm going to go over 6 on the x component here, 1, 2, 3, 4, 5, 6. And then I'm going to move up 4 in the j component, 1, 2, 3, 4. And it would actually be this point right here. Okay, so it was a point. That's how that would graph. If it was a vector, remember, it would have a direction and a value right there. Okay, so if we look at this, we're looking at this side is 4 and this side is 6. So if we wanted to get the components that we needed to do it for polar, what we need is we need the hypotenuse and we need the angle. Okay, so what's the easiest thing to get first? Maybe to get the hypotenuse, and we know for the hypotenuse that c squared is equal to a squared plus b squared. So we take 4 squared plus 6 squared. Okay, so c squared is equal to 4 squared is 16, and 6 squared is 36. Okay, so we got c squared is equal to 36 plus 16. Looks like 52 in my book. And then we need to square both sides right here so that we get 6, or c is going to be equal to the square root of 52. And it's like 7.21. Okay, so this length right here would be 7.21. That's my hypotenuse. And then what we would need would be the angle for the polar right here. And so what do we need to do for that? Well, we need this angle right here. And we have the opposite side and the adjacent side. So if you look at SOHCAHTOA, we're dealing with the opposite and the adjacent. We're not working with the hypotenuse. No, we're looking at TOA, which is tan. Tan of the angle is equal to the opposite over the adjacent, okay, which is equal to 4 over 6. Now remember, we want the angle, so we got to do the inverse tan here to get the angle. So if I go 4 divided by 6, 4 divided by 6, and I go inverse tan, I get 33.69. And that's what this angle is right here, 33.69 degrees. Okay, so if I were going to plot it here, here's my 30, and I'm at units of 7, so I'm going to draw it in light in here. It's kind of coming up just a little bit more than 30 because it's at 33 degrees, and 7.21. So 1, 2, 3, 4, 5, 6, 7, and a little bit more. So there's my point right there. There it is, and then if I wanted to make it was a vector, it would be looking like that, and it would be 7.21 at an angle of 33.69 degrees. All right, let's do another one here. So that's going to do to another one. It wants to plot the point -5, and then here's our complex or imaginary part J3. So remember, this is my axis here for my imaginary, and so what this is going to do is going to be -5, and that's going to be the horizontal axis here, 1, 2, 3, 4, 5, and then we're +3, 1, 2, 3. Okay, so there's my point right there. Okay, now this is in quadrant 2 right here. Okay, that's why we're doing this one right here, because if we look at this triangle right here, we need to apply a couple of these angles to our polar, realizing that we're in quadrant 2. All right, so what do I have? I have that this side is 3 and this side is 5. So I can get my hypotenuse by going c squared is equal to a squared plus b squared. So c squared equals this equals a squared, which is 3 squared plus 5 squared. Looks like c squared is equal to 3 times 3 is 9 plus 25. So if I take the square root of these, I get c, and I'm taking the square root of this side here. So 9 plus 25 is, looks like 34. So if I square root of 34, I get 5.83. Okay? So that's how long this side is right here. Great. Now I need my angle right here. And we have the opposite and adjacent again, just like we did before, where we use tan is opposite over adjacent, tan of your angle. So my opposite is 3. My adjacent is 5, but I want the angle, so I got to take the inverse tan. So if I divide 3 by 5, 3 divided by 5, that's 0.6. That's 0.6, by the way. And if I go inverse tan, 30.96. 30.96 degrees, okay? And so that's what this angle is right here. Okay, so the issue here is that we don't designate the angle from this point over here, or from this direction here. The angle is going to be given this way in that direction. So what is that angle? It's not 30.96. We have to recognize that half of this is 180 degrees, okay? And so this must be less than 180. It must be 30.96 less than 180, all right? So if I go to 180 minus 30.96, I get minus 30.96, I get 149.04 degrees. And that's what this here is, 149.04 degrees, because remember, these two must add up to make 180. So if for some reason your vector, your point lands in quadrant 1, well, you don't have to do any manipulation of it because this is 0 to 90 degrees. If it's in quadrant 2, you're going to have to subtract from 180 to get this, right? Quadrant 3, be aware that whatever angle you get, so you got angle, you'd be adding to 180 because it's from here. And then quadrant 4, this is 270 degrees here. This is 0, 90, 180, 270. So your angle would have to be adjusted by adding 270 degrees onto that to get the angle from 0, or it could be a negative angle from 360. You know, it could be minus 30, or it could be minus 30, or it could be 330, something like that. So keep in mind that your angle has to be adjusted. But what we have is 5.83 at an angle of 149.04 degrees, not 30.96 degrees, 149. So what are we going to do? Here's 120, here's 150. It's about 150. I'm just going to draw a light line kind of next to it because it's pretty close, and I'm going out 5.83. 1, 2, 3, 4, 5, 6. It's a little bit less. Here's my point. And my vectors, it would be a vector, it would be going like this, right? Be coming through there. And then we'd be looking at this point right here of 5.83 at an angle of 149 degrees. So there are your complex numbers. They go on the rectangular coordinate system pretty easily. And you're going to use the same formulas. You're going to use tan. You might have to adjust it a little bit. And you're going to use Pythagoras theorem, and you'll be able to transfer it over to the polar.